Okay, so in this video I'd like to tell you about auroras and where their colors and stuff come from. So basically we have this setup that we've been discussing for a while. We have the sun here, and it looks like a big coronal mass ejection is coming off in a minute. And the sun's kind of a mad object, I guess. I've been sort of describing it as. And there's a big coronal mass ejection coming out. But if not for that, of course, we know there's always this solar wind coming out, which is this collection of protons and electrons which are just streaming across the solar system, and here they come. There's the Earth over there, and remember we have this magnetic field around the Earth. And there's some of the lines that I'll draw that sort of look like that bar magnet pattern that I showed you, because the Earth's magnetic field behaves like there's a bar magnet. There's a north and south pole, but if you look at the north and south pole, there's these little dips in the field. They get awful close to the Earth. You can see them in this a little bit too. So here's that animation coming. There's the Earth spinning there. And here comes a big coronal mass ejection or a big burp from the solar wind in a minute. And you can see the magnetic field around there. Here it comes, and it comes on out. And then suddenly when it hits the Earth's magnetic field, it just sort of goes around the Earth because of that magnetic field. Let's watch it one more time. So look at the Earth's magnetic field, happily spinning in there, but has a magnetic field around it because it's spinning. I'm not sure what that little tunnel is in there, but just for effect. But here comes either the solar wind or the coronal mass ejection. And it just goes around the Earth because of the magnetic field. So I'm not sure how accurate this animation is here, but remember the solar wind is definitely going to go up and above the Earth, the way I'm trying to draw here. So these purple lines are sort of going between your eye and the graphic of the Earth here, going above it. I'll draw them a little thicker there, indicating that it's going above the Earth, like that and like that, just sort of going around. So these are the things that the solar wind is going above the Earth. And so that's sort of the protection mechanism in there. So it just sort of hits the field and just goes up and around like that, not directly hitting the Earth. And so what I wanted to point out here was you can kind of see the point I'm going to get into. There's the coronal mass ejection coming out. Of course, the solar wind is coming. And there's those dips again in the magnetic field. You can see those, just the bar magnet pattern. And here comes all that stuff from the sun, and you can tell that there's an opportunity for the stuff to sort of get into those dips. You can see the orange shading just a little bit in that graphic right there. But that's what causes these beautiful northern and southern lights. So they're beautiful on the one hand to see, but on the other hand they're caused by the solar wind, so they're kind of bad. But this is what you would see when the solar wind penetrates into those dips in the Earth's magnetic field. So let me show you where that comes from in a little more detail now. So there's the Earth. And there's, say, the North Pole, okay? And there's the magnetic field lines in that dip, just the pattern that bar magnetic field pattern forms. So there's the dip right there, which you sort of can't get away from. And there's the Earth there, so say you're standing there on the North Pole. And what will happen then is, of course, the Earth is surrounded by its atmosphere. So these little dots that I'm putting in there are the nitrogen and oxygen that form the Earth's atmosphere. Nitrogen and oxygen, that's primarily what's in our atmosphere. And so you can't forget that the auroras, the colors actually come from the atmosphere. So what will happen now is when the solar wind comes in, gets into that dip, they'll collide with the nitrogen and oxygen molecules in the atmosphere. So these orange things are these solar wind or a coronal mass ejection sort of getting into the dips there. And let me just get my slides worked out here. Here we go. Here's the Earth one more time. There's that magnetic field again. There's the Earth's atmosphere one more time. Sorry about this, I lost my graphics. Here comes the solar wind finding one of those dips and just penetrating really, really close down to the Earth's surface. So close that it's actually getting near the atmosphere, into the atmosphere, and that's where the colors are going to come from of the aurora. So here's a nitrogen molecule, and here's some protons and electrons coming in, the solar wind maybe colliding with a nitrogen molecule like that. When that collision happens, maybe green light will come out, maybe some purple light, maybe some red light, something like that. The same thing could happen with an oxygen molecule in our atmosphere. There's a collision with a solar wind with an oxygen molecule, maybe some purple light, red light, green light might come out. But it's those molecules that cause the colors that we see of the aurora to happen. So if it wasn't for the atmosphere, there'd be no colors. If it wasn't for the weak spot, there'd be no colors. But the colors come from the molecules in our atmosphere, primarily nitrogen and oxygen, N2 and O2. So it's very elemental, like the colors come from the very definition of the elements themselves. And so, of course, that's what the aurora are, a combination of the solar wind penetrating into the weak spots in the Earth's magnetic field, interacting with the nitrogen and oxygen in our atmosphere, and that's where those beautiful colors come from. So those colors are glowing nitrogen and oxygen molecules as stimulated by the solar wind. And they can be lights in the north or south. They're very beautiful to see. But on the other hand, they're made by that solar wind. So even the more intense or more beautiful they are indicates some sort of bad solar wind activity. So they are sort of double-edged sword, right? Very beautiful, but caused by that solar wind. So they're sort of awful all in the same bit. And that's why they're always in the far north or far south of the world, because you need to be where those dips in the magnetic field are. So there's some greens and some reds. But just remember, the more intense or more beautiful they are, indication or evidence that the solar wind is real and is happening. So another evidence point for the solar wind.